good.
We are good to go. Perfect, perfect, perfect. Okay. I was just telling them while we were on break that 3 people have taken the test. A couple of them went up, how many points did I say? 11? 12 points and 20 points. And they said that the reason they went up was by doing that 14-page review that I put out there. Just going through and working those problems. And I didn't do one for 7 and 8, but I said the easiest way to do it is to sit down when you're doing nothing. And I've already done the first 3 just by sitting here. And I was looking at number 4. It says, identify the properties of a normal curve. Page 367, definition. So I'm in the electronic textbook. I go to page 367. And on page 367, there should be something about the properties of a normal curve. And the only thing that's on there talks about down here. So I'm just going to, it's talking about drawing a normal curve, area under a curve. So I'm just going to take and pull that in there. And I'm also going to pull this example in there. Copy. And I just did it in your notes. So I've really just done the first 4 questions of your test review. I'll even write it out here. 4 of 20. So this was number 1 off your spreadsheet review, 17 and 18. This was number 2, it said 25 to 28. This was number 3, it said a definition off of some page, and this was number 4. So I just quickly went off those pages. So I've done up to number 4. And your next test, not the one that's due Wednesday, but the 7 and 8 test, has 20 questions. It's on 7-1, 7-2, 8-1, and 8-2. So I was just quickly going through and just marking some stuff off. So I've already done 17, 18, 25 to 28, and those 2 definitions. So you can easily just pull those off, but they said that's how they got their grade to be so high, is to do those 14 pages. And to show you, I put those 14 pages in several different locations, and I think I even emailed it to y'all. Oops, content. I want to say that I put it under the notes, under Ms. Cooper's notes. I put it out there, and I also put it under the unit review so that you can pull it in either place. And not only do you need to do the problems, you also, so if you go to Ms. Cooper's lecture notes, Ms. Cooper's lecture notes, and you scroll down to the week before the break, a minute ago. But if you scroll down to a week before the break, we had the notes from the day that we got out, that Wednesday before the break, and then right below that I called it the chapter 5 and 6 review problems or something. It's out there under that page. And I also put it out, I couldn't get that page to come up earlier. I also, watch me, I've already made it back. Oh, there it is. I also put it under the unit review. Maybe I can get that one to come up quicker. Unit test and final exam, unit reviews, to unit test review. And if you go to unit 2, I have it out there as well. There's the review sheet, and then here's the test review problems. That's the one that was those 14 pages. And then there's the solutions manual so that you can check them. But I have it out there as well. And you can even download it and save it onto your memory stick or whatever, but you can work those out as well. So there's another way that you can get ready for the test. All right, so, but I just stuck those slap dab in the middle of your notes. All right, let me see where we were. Let me move that down because that's where we went to break. So I've got 2 pages right there. Now, let me cover this up. We are still in 7.1? Yeah. 7.1. This says the monthly charges for a cell phone plan in the United States have a normal distribution with a mean of 62 and a standard deviation of 18. Draw a normal curve with the parameters labeled. We can do this in our sleep. This is telling us we have a normal distribution, a mean of 62, and a standard deviation of 18. So that's what they want us to do for Part A. Just draw what they're telling us in the directions. Shade the region that represents the proportions of plans that charge less than 44. So 44 is our data point. $44 is our data point, and 44 is less than 62, so I put it on the left. And because we're doing less than, we're going to shade below it. So that's going to be Part B. We good? Part C. Suppose the area under the normal curve to the left of 44 is 0.1587. So now it's telling me that the area in yellow is 0.1587. It says provide 2 interpretations of this result. So what does that 0.1587 mean? And I've written 2 sentences, and I'm going to show you. There's just a bigger, prettier graph. Now, when I drew the prettier graph, let me draw my line here. This was my mean. I had my standard deviation of 18. And then from the 62, I added 18, added 18, added 18, and subtracted 18, subtracted 18, subtracted 18. Then I started at 44, which was my data point. It was less than 44. And then it told me 0.1587 was my proportion or my percent underneath the curve. Then in question C, it says, what does that 0.1587 mean? Well, if we whoop that, do you agree it turns it into a percentage? So 0.1587 means 15.87% of the cell phone plans are less than $44 a month. So if my cell phone plans are a normal distribution with 62% is the average bill with an $18 standard deviation, 15.87% of the people pay $44 or less. I probably wouldn't be one of those. Now the other one says the probability is 0.1587 that a randomly selected person has a cell phone bill that is $44 or less a month. So if we turn it into a whoop, it's a percent. If we don't whoop it, it's a probability. But they're showing you that that shaded amount is either going to be a percentage or it's going to be a probability. So anytime that you're looking for this shaded or you're giving this shaded, it's either going to be a percent or it's going to be a probability. So that amount underneath is either a percent or a probability if it's shaded. We good? And we really did this when we did the empirical rule, when we did the 68, 95, 99, 7 rule. We've already talked about this a little bit. Now, where did the 0.1587 come from? They gave it to us, but we want to know where did it come from. Now, there's 2 ways that we can get that 0.1587. If I come back and I draw that my mean was 62, my standard deviation was 18, my data point was 44, and we're shading to the left, okay? Now, we're not going to use the empirical rule, the 68, 95, 99, 7, unless they tell us to. Now, we haven't talked about the formula sheet a lot, so I'm going to bring up the formula sheet for just a minute. See if I can find my little... On your formula sheet, you had a table. It's called Table 5. Let me find it so that we can talk about it for a minute. And I'm not going to spend a whole lot of time on Table 5 because your calculator can do everything that Table 5 can do. But I want you to be familiar with it just in case somebody says, oh, you need to use Table 5. Table 5 always gives me the area to the left. So anytime we're doing Table 5, we're always talking about the area to the left. Okay? Now, in order to use Table 5, you've got to know the z-score. So for our problem, if we were to do this old school, we would have to know the z-score. So old school, we're going to use the Table 5 and we've got to know the z-score. Now, do we remember how to find the z-score?
It had something to do with the quartiles, didn't it? No.
We did talk about quartiles of z-score.
For some reason, I felt like it was like Q3 minus Q4.
Oh, you're close. Data minus mean over standard deviation. Data minus mean over standard deviation. So what would my data be? What's my data point? 44. Minus, what is my mean? 62, and what is my standard deviation? 18. So to get my z-score, I would do data minus mean divided by standard deviation. So my z-score is a -1. So when I come over to this table, I am going to use a z-score of -1. So if I scroll down, my z-score is -1. So it is -1.00. Let me give you another one. What if my z-score, before I do this one, what if my z-score was negative, it's not going to let me write on there. Let me suck this over so I can write on it. Copy. What if my z-score was -2.43? I would do -2.43. That would be my answer. So this is the first 2 digits, and then up here is your last digit. So -2.43 would be -2.4, and then the 3 from there. So you would come over and then come down, and that would be your answer to the left. So that's saying if your z-score was -2.43, then the area under the curve to the left is 0.0075. Does that make sense? So for our problem, our z-score is -1, which means it's -1.00. So we're going to have to go -1.00. That's where the 0.1587 came from. So we are -1.00. That's where the area under the curve to the left. So if our z-score is -1, the area under the curve is 0.1587. Now, what if I gave you a problem and I wanted to know the area to the right. And let's say our z-score was, let me pull up the table. Just gonna pull up a piece of the table, copy, paste, and then let me get the top of the table so that you can see. Copy, paste. Let's say that our z-score was 2.45. Okay? So if our z-score is 2.45, what is the area under the curve?
0.9929.
Are we good? So a 2.45 gives me 0.9929. Now, this is like Beyonce. To the left, to the left. This table is always to the left. Who knew when she was singing she's talking about math? Always to the left. So this represents the area to the left. So when I have a z-score, it's a positive. That's why I know this on this side. So it's 2 jumps and a little bit more of a jump. So the area underneath the curve is going to be, to the left, is 0.9929. But I said I wanted it to the right. So I want this side. So how am I going to get that side? 1 minus. So to get my answer, I'm going to do 1 minus. I don't know what I just did. So to get to the right, I'm going to do 1 minus the left. So I'm going to do 1 minus the 0.9929. So it's going to be 1 minus 0.9929. So the answer to the right is going to be 0.0071. Kind of like, Rachel, when we did that reject, we had to do the accept and then do 1 minus reject. When you're doing the table, you're always doing to the left. So if they want the to the left, that's your answer. But if they want the to the right, you got to do the 1 minus to the left. Because this is the Beyonce table. We good? Now, here's the good news. Your calculator can do all of this for you. You don't have to do the table. I'm just showing you that the table is there if you're a table kind of person. Now, if your homework says use table 5, this is table 5, and it's on your formula sheet, but your calculator is always going to give you the same answer because they're going to say round to 4 places. All you got to do is round your calculator to 4 places, and it's going to give you the same answer. Okay? So, let's talk about how to do it the other way. So, old school, just to show you, old school, what I did is I did data minus mean over standard deviation. I got my z-score, and then I went to the table and looked up a z-score of -1, which was here, and that gave me my 1587. That's where that 1587 came from. So now we're going to learn how to do it on the calculator. So let me go. And this is reminding you that table 5 shows you the calculator only. Calculates to the left only, like the Beyonce song. So let's show you how to do it in the calculator. When you're doing your normal distribution, you've got your mean of 62, you've got your standard deviation of 18, you've got your data point. The question said that we were going to do shading to the left. Now, they do left bound, upper bound in your calculator. Left bound, this is your left. Left bound is where you start shading on the left. So when I started shading on the left, I was at negative infinity. Right shading is where I stopped shading. I stopped shading at 44. So I started shading on the left and I stopped shading on the right. So left shading is my lower bound. Upper bound is where I stop shading. Now, we can't type in our calculator negative infinity and positive infinity. Negative infinity is when I go forever this way. Positive infinity is when I go forever this way. So negative infinity, we do 9, 9, 9, 9, 9. Positive infinity, we do positive 9, 9, 9, 9, 9. That is telling my calculator that I'm going to go forever in a big number or I'm going to go forever in a small number. And I'm going to do a lot of these. These are super easy once you draw your picture. So for this problem, they are normal CDFs. This is your left shade, your right shade, your mean, and your standard deviation. So, where did I start shading on the left? At negative infinity. So we do negative 9, 9, 9, 9, 9. Where did I stop shading on the right? 44. My mean is 62 and my standard deviation is 18. So it is normal CDF. Now, because you're telling the calculator where you stopped and where you started, it's not like the table. It's not always to the left. You're telling the calculator where you're starting and where you're stopping, so you don't have to do the 1 minus. Your calculator will always give you the right answer. So we are going to go to our calculator and we're going to do the second bars. And this time we're doing normal CDF. We're not doing what we did on that last test. We're doing normal CDF. So normal CDF, negative 9999, comma, 44, comma, 62, comma, 18, and there's my answer. And they always want you to round it to 4 decimal places because that's what the table gives you. So this is telling me that it started shading at negative infinity, it stopped shading at 44, my mean was 62, and my standard deviation was 18. So that gives me that this is the percent under the curve. 0.1587 is my percent under the curve. So if I had to draw this, my mean is 62, my standard deviation is 18, my data point is 44, and I'm shading to the left. Yes, boo-boo? Did you do normal CDF?
Yes, ma'am.
Okay, let's see. Let's see what you're doing. This you did a decimal, and this you did a decimal. It should just be negative 99999. All right, let's look at another one. Now, I did write down all the steps. You make a drawing, the normal distribution, you label the mean, you label the standard deviation, you do your shading. Your lower bound is on the left, your upper bound is on the right. You do second bars, you go to number 2, which is normal CDF. You enter your lower bound, you enter your upper bound, you enter your mean, you enter your standard deviation. Close your parentheses. So I listed it all out in case you need to go back and look at it. All right, so here's our first problem. We have IQ scores. They are normally distributed with a mean of 100 and a standard deviation of 15. What is the probability? Probability means area under the curve. That an adult scores less than 120. Let me move this up so that we can look at it. So the first thing you need to do is draw you a cute little picture. We have a normal distribution. The mean is 100, the standard deviation is 15. Our data point is 120, and we're doing less than 120. So the first thing I'm going to do, let me come over here. So I have a normal distribution with a mean of 100, a standard deviation of 15. Now, 120, is that going to be to the left or to the right of my mean? To the right, because 120 is bigger than 100. Am I shading to the left or to the right of that point? It is less than 120. So I'm going to shade to the left. So that's what my cute little picture looks like. We good? So I'm going to do the normal CDF. Where did I start shading? Who?
119?
Start, when you're driving your car, you drive from left to right. You read in English from left to right.
Negative.
Negative 9999. So you started here. So it's negative 99999. Where did you end your shading? 120. What is your mean? 100. What is your standard deviation? 15. So when you do your shading, it's like you read from left to right. You always do your shading from the left side to the right side. So it's negative 9999 to positive 120. Then your mean, then your standard deviation. So when I go to my calculator, it is going to be second bars, normal CDF, negative 99999, comma, 120, comma, 100, comma, 15. So this represents the area under the curve. That's the probability, that's the percent. So if I said what percent of this normal curve is shaded, what would you say? What percent? 90.57 or 90.87%, 88%? So let me pull down and show you the cuter version of this. Are we good with that one? What is the probability that an adult scores greater than 120? Y'all, let's think. If we just did less than 120, how do we do greater than 120? 1 minus. So we really didn't need to do all of that. We could have done or 1 minus the 0.9087, or was it 88? 88. Which is going to give me 0.0912. Now, just to show you what they did it the long way. They said that our mean is still 100, our standard deviation is 15, we are doing 120 or greater. So what is my left shade? Where did I start shading on the left? 120. Where did I stop shading? 9999, my mean and my standard deviation. It's going to give me that same answer. But since we did the more than 120, the less than 120, we could have easily done the more than 120 because we know they add up to 1.
So these have the same rules that to memorize. But and is it always, except, so if it's equal, then it'll just be normal PDF?
No, this is always going to be normal CDF.
Okay.
It's always going to be for these, normal CDF of the left shade, right shade, mean, and standard deviation. So whatever shaded on the left, whatever shaded on the right, the mean and the standard deviation. That is if you're trying to find the shade, if you're trying to find what's underneath.